New York City's skyline is iconic, but for building owners, it represents a changing landscape of regulations, rising costs, and urgent carbon mandates. The pressure is on to reduce energy use and emissions without bankrupting the budget or disrupting the lives of tenants.
Over the past few years, specifically the last 3 years, our utility costs kept growing because the price of steam and the price of electricity increased every year by at least 10%.
150 West End Avenue is the quintessential early 1960s New York City high-rise. It incorporated all the things they learned up to that point, including central heating and cooling, larger windows. Well, the central ventilation systems were built to be oversized to begin with. They were also built of masonry, which wasn't very tight, if you will. It's like trying to drink from a cracked drinking straw. And so because of the leaks, they had to put bigger fans on the roof and exhaust so much more air just to serve the kitchens and bathrooms systems designed to serve. As a result, more than 50% of the air being exhausted from the building was wasted. It wasn't serving the apartments at all. And all that air was taking all that energy with it.
The higher floors got a lot more exhaust than the lower floors. So the whole building, the positive and negative airflow, it was all out of whack, out of balance.
There was little that could be done to address the energy waste of the ventilation system if the leakage wasn't solved. The fans were replaced, but when turned down to reduce the energy use, the system stopped working properly, requiring that the fans be sped up again. It didn't make a dent in the steam usage and utility costs because they were only treating a symptom, not fixing the real problem, which was the leakage.
Stephen Winter Associates works on consulting for accessibility, energy efficiency, decarbonization, and health. We work with policymakers, program implementers, and with private developers and owners to make sure that their buildings are performing as best as possible. On this particular project, we were brought in to be a third-party technical reviewer. There were already other sets of eyes on the project because Con Edison is involved, and there was measurement and verification scope. We came in to be a third-party review of the entire scope and the analysis.
I was a little worried about Aeroseal repairing the ducts, and I was worried about scheduling, getting into the apartments. How is this gonna all come together? Gaining access to all residents' apartments gave me some anxiety.
Aeroseal works by sealing the ducts from the inside. We don't have to tear the walls down to get to them. We actually just block off all of the intentional openings, and then we can pressurize the duct, send our sealant down into the duct, and it finds every gap, crack, and hole and seals them with a non-toxic sealant.
On the first day of sealing the riser, it was incredible. I witnessed the manpower and the organization and everything that went into it, all the details that correlated into making this technology work. So I would say it went a lot smoother than when I first heard about it.
By sealing the leaks and balancing the flows, the project cut the building exhaust by 75% without sacrificing the ventilation performance. That reduction saved steam use, as well as cutting the electric use for the fans and for the central chillers that are used to cool the building in the summer. This resulted in over $241,000 of total annual utility bill savings while avoiding 208 tons of CO2 equivalent in steam usage within the first 4 months, all with a less than 4-year payback period before incentives.
The energy savings that Aeroseal was stating made sense from a technical perspective.
So we were very excited about the results we were able to achieve with this project. We've reduced their steam use by 30%. And even when the cost of the steam has gone up 40% in the last 2 years, they're pretty much heating the building this year for the same cost they did 2 years ago. This also is a huge decarbonization opportunity. We're eliminating many, many tons of carbon from being released into the atmosphere, which is a really big deal in terms of being able to try to control climate change. And so that's a really big win for us. It's a big win for the building. It's a big win for the planet too.
Ventilation optimization isn't just a repair. It's one of the most cost-effective, least disruptive ways to reduce utility costs and carbon emissions.